morning, ladies and gentlemen. I welcome you again for this another class that we are just going to begin right now. Before I start it, let me first humble myself with a word of prayer. King of Kings and Lord of Lords, Jesus Christ, the Creator of heaven and earth, I thank you for having me to reach here on time. And King of Glory, I request for the anointing from heaven to descend on me and give me better explanations. As Father, your children's who are going to listen to this video that is being made today, let them, Father, be able to receive the total anointing of understanding, and the knowledge that they're going to use to get from this should not only end here, but they should use it to prosper or to excel in their careers. Father, I thank you, honor you, protect us, be with us, and make us, Father, to follow the rules and regulations for our Ministry of Health and any other procedures that is required to make us prosper. In Jesus' name I've prayed. Well, we are just going to look at, there's a new chapter that we need to look at. I've decided this one here to actually to do a presentation of it because it has so many new ideas, and this chapter is very important. Some of you who have plans to do might be network security in the future at your master's level, or maybe to excel you need to do CCNP in Cisco, and it might be expert and some other things. This thing will assist you to make sure that you understand most of other algorithms that are done, and this is what I call STP in bracket spanning tree protocol. This is spanning tree protocol. We are going to look at it practically. We shall look at it practically, and then but it is too much of explanation and understanding the concepts that are inside this this chapter. So that's why I've decided to make sure that at least we can present this module 5, that is STP concepts, that is now looking at the spanning tree protocol. A spanning tree protocol is a protocol that is used on Cisco devices, and this protocol is actually developed using either C or Java. You can use even Python altogether to come up with STP. This STP is an algorithm that is used to solve problems. You remember when we are talking about the problems in mesh topology, whereby you're using a mesh topology and then you find out that there's a crossing of of packets, and then they make loops. More especially when you're using a ring topology, you know that there is always a challenge of coming up with the loop. So those loops are cancelled out by STP. So STP is a protocol that is designed in an algorithm that can be able to cancel out those problems. So we are continuing, and then we shall be able to see. So we look at this PowerPoint instructors planning guide, and this is just the guides of what we are supposed to look at. And then the PowerPoint deck is divided into two parts. We have instructor planning guide and information to help you become familiar with the modules, teaching aid, and instructor class presentations. So this is just an outlook of what is supposed to be done. So what is expected in these modules? These are now what we could call the objectives, because the modules of these of nowadays now, they have changed them a bit. So you look at these animations, video, check your understanding, and you can interact with the activities, syntax checkers. So these are the things that will be involved there. Check your understanding, getting it. So then activities can be given to someone, to students getting that. Yeah, video, observers, STP operations, investigation of STP loops, presentations. So these are the things that we're going to look at down there. The best practice, we find that to have the the activities and assessments for this module, try to include as many questions and ask the students or have class discussions. So just trying to look at this. So its concept now, it is beginning here at this particular time. So look at STP concepts. Explain how the STP enables redundancy in a layer 2 network. So now you see that we have a topic title, which is the purpose of STP. And then we have the objectives here. Now, the purpose of STP is to explain the common problems in redundant layer 2 switched network. Are you getting that? So this is what I've told you, that when a packet is sent within a network, more especially when the nodes are connecting to each other. Are you getting that? That's when you have here a router, you may have here a router, have another one here, have another one here, have another one there. Are you getting that? Then you interconnect all of them. I think that. So you find out that when a packet is moving in this network, some of them will be are getting some challenges, because when a packet moves here, moves there, so every node may end up sending, and then it creates what I call a loop, and then it will result to no communication anymore. So the STP is explaining how the redundancy can bring problems in a network, like in layer 2 network, and then how can it be solved. Then STP operations. What is the operations? How does it operate? Explains how the STP operates in a simple switched network. So it will explain the simplest ways on how the STP can be able to be working. So evaluations of STP. It can be evaluated by seeing how on its results. Explain how the rapid PVST plus operators works. Are you getting that? So those are now some methods that will be done, but this part here will not be covered in this chapter that we have. It will be covered in another chapter in front there, and I hope this is where we shall be doing its configuration itself altogether.
That this new thing that has happened has surprised all of you.
The purpose of STP, redundancy in layer 2 switched network. This topic covers the causes of loops in layer 2 network and briefly explains how spanning tree protocol works. Redundancy is an important part of the hierarchical design for eliminating single points of failure altogether and preventing disruptions of a network services to users. For example, you see, we are saying that creating redundancy, this is creating too much paths for the device altogether. So redundancy, when we are creating redundancy, I hope you guys, all of you, you know altogether. In most cases, when we are making redundancy, we don't always try to mean something else. When we're making redundancy, we create so many things that makes us to get this. You may put here a PC, put another one here, you put another one here, put another one here, or another one here. So you cross them like this, connected, like that, all together. So when you do that, you find that the path will be moving, the packets will be moving from different what? Nodes. But when it takes a certain node and maybe that node is blocked, then it will use an alternative what? Route. So that is redundancy in path altogether. So for us, we make loops in a network to make sure that there is no point of failure within our network, more especially mesh topology. But we know again, after creating redundancy, it brings the problems of loops altogether. Now, how can we overcome the loops? Is it okay? Yes. So overcoming the loops is now reducing or removing a node or an edge that cannot lead to loops altogether. And then we continue communicating. So redundancy is an important part of the hierarchical design for eliminating single points of failure and preventing disruptions of the network services to users. Are you getting that? Yes, disruptions whereby a person has sent his work, but his work has not reached who it is supposed to reach due to the point of what? Of failures or problems. So redundant network requires the additions of physical pathings. I think that. So STP will be required, but logical redundancy must also be part of the design altogether. Having alternate physical paths for data to traverse the network makes it possible for the users to access the network resources. Despite path disruptions, however, redundant paths in a switched Ethernet network may cause both physical and logical layer 2 loops. I see now. So we are saying up here that creating redundancy or creating loops is actually very important, because it makes us not to have any point of what? Of failure, and preventing any disruptions that may occur somewhere. But as we do this, we also create a problem in a layer 2 switched network, whereby physical and logical are together. So the Ethernet LAN requires a loop-free topology with a single path between any two devices. A loop in an Ethernet LAN can cause continued propagations of Ethernet frames until the link is disrupted and breaks the loop altogether. Yeah, so it will be sending packets, and then they will continue being in a loop on a loop until the loop does what? Reach an extent of being chained. So spanning tree protocol. So look at this now. This network already, there is a loops here, as you can see. In any communications of the network, so we expect that when you connect the switches, one of the switches will be a master. There must be a server in them, and others will be clients. But how do they become? A spanning tree protocol, STP, is a loop prevention network protocol that allows for redundancy while creating loop-free layer 2 topology. So it is the STP that breaks the loops within the network altogether. So you see that if this is the master, I'm assuming, and then a packet, you see this one will send. If this link sends, and this one will send, because there's this device that is sending. Are you getting that? If now this one is coming here and is a broadcast message, because this one will send a broadcast message. When a broadcast message sends from here, automatically you like your note, it will be sent this side and also here, because it is a broadcast what? Message. So when it comes, this packet continues coming. When it reaches here, it will also come this side. Also this one here, when it comes here, it also come this side. This one will come and reach here. This one will also pick the same packet. Remember, the packet is moving here and here, they are the same packets. So when this one comes here like this, it will reach here, this one will make it continue, and also this one that has come here will also leave and continue and also come. So you see that the same packet will continue making a loop altogether. As this one sends it to these sides altogether, but another one will have gone this side, and then you find yourself that now you have made a loop in such a network. Why? And this loop will not be broken if the spanning tree protocol is not enabled altogether. Yes. So in this type of network, you expect a communication to be done once, and you will not communicate again. Why? Because the redundancy, the packet, the empty packet will continue moving, occupying the what? The link. STP logically blocks physical loops in a layer 2 network. So you can see that now physically it has blocked this. You will see that this one is like as if it is blocked, meaning that this link here is like as if it is not there. So the only link that is working is this. We are going to see these links. We shall have designated, we shall have the stateful, we shall have what? All those ones. So this is how it is, preventing frames from cycling the network forever. Are you getting that? So it will be avoiding blocking this one here. It is avoiding the other method, the other problem of the packet which has passed here to continue this side. When to reach here, it will find that this port is blocked, therefore it cannot pass there. Also this one, when it comes reaching here, it find out that this port is blocked, it cannot proceed. That means already the STP will have solved the problem. STP recalculation. STP compensates for the failure in the network by recalculating and opening up previously blocked ports. This is when now, when you look at the first diagram, it recalculates, and the recalculation will go either on the time altogether, the time taken on the bandwidth length altogether. So if it realizes, and it will always, you see, when you have a master, it will be changed depending on the master. All the ports coming out from the master or the king or the queen, we can call it a queen or king, that one there, all of them must be designated. In other words, they should forward packets. But all other ones should be blocked. So you can see that when it recalculates again, maybe these ones shall be doing them practically. I shall show them to you again practically. But in this one here, I just want you to get the knowledge of STP. What does it do exactly? That's the reason why I wanted to present this altogether. So you find out that now when it recalculates, that is when probably you have change the priority of a certain switch in layer 2 altogether, because it looks at the priority, the one which has a high priority, and the priority will be calculated depending on the one which has a lower MAC addresses. Are you getting that? So it will change. So when it has changed this port which was blocked the other time, now it has changed, it is now this one, meaning that the master in this topology has changed. If I come to this topology, you find that this is the master now. This one is the what? Is the master. And now when you come to this topology, now this is the what? The master, meaning that the port which is blocked need to change as well altogether. Then issues with redundant switch links. Path redundancy provides multiple network services by eliminating the possibility of a single port of failure altogether. So it will always create possibilities of how they can get a point of what? Of failure. When multiple paths exist between two devices on an Ethernet network and there is no spanning tree implementation on the switches, layer 2 loops occurs. I think that we had already said that in case if the redundancy is created on layer 2 switches, that is now creating different or a mesh topology on layer 2 devices. When you create them, automatically the loops will do what will occur if the STP or spanning tree protocol is not enabled on those switches. Are you getting that? So the layer 2 loop can result in a MAC address table instability link saturation and high CPU utilizations on switches and end devices, resulting in the network becoming unusable. Are you getting that? Now what happens that now the CPU and even the RAM will be overwhelmed because the MAC address of one single device will keep accumulating or filling up the CPU processes or executions. Are you getting that? So it will be fed up. It will be flooded with a lot of MAC addresses, which MAC addresses is the same MAC addresses. Therefore, it will make the failure or the failure of any communication within that network. That's why I said at first that in a situation where there is loops or in a network where you have loops, there you expect a single communication. The communication is done once and it cannot be done. Why? Because this packet continues moving around the network and then the path becomes occupied. If you remember our CSMA/SCD and CD, those ones there, that keeps monitoring whether the media is free and which device is sending the message. Are you getting that? So those ones will keep monitoring. Whenever a PC try to send a message, is the media free? Should I be able to send? Always the media will always tell you that the media is occupied, meaning that you don't expect any communication because the media is occupied by an empty packet, which was already communicated maybe 10 minutes ago or 100 times ago. I think that. So it will continue and then the loops will be making the network to fail. Layer 2 Ethernet does not include a mechanism to recognize and eliminate endlessly looping frames. Are you getting that? So it cannot recognize those ones. Both IPv4 and IPv6 includes a mechanism that eliminates the numbers of times a layer 3 networking devices can retransmit packets. This is now when you are introducing in this network a layer 3 device. That is now a multi-layer switch, or you can use a router, which keeps what is local to remain local altogether. A router will decrement the DTTL time to live in every IPv4 packet and the hop limit fields in every IPv6 packet. Then, when these fields are decremented to 0, a router will drop the packet altogether. That is when it has realized that the packet is not supposed to be forwarded. Ethernet and Ethernet switches have no comparable mechanism for limiting the numbers of times a switch retransmits. So for it doesn't have that methods of how many times the switch should continue doing one, transmitting the packet in layer 2 frames. Therefore, we use STP was developed specifically as a loop preventations mechanisms for a layer 2 Ethernet altogether. So STP was their spanning tree protocol. It came because it doesn't have, the switch doesn't have the mechanism to limit this. So they introduced STP mechanism or algorithm to solve this. Layer 2 loops. Without STP enabled, layer 2 loops can form, causing broadcasts, multicast, and unknown unicast frames to loop endlessly. This can bring down the network quickly altogether. So in case if the STP is not enabled in your switches, then it will always bring these problems, and obviously you'll be always in failure of communications. When a loop occurs, the MAC addresses tables on the switch will constantly change with the updates from the broadcasting frame, which results in a MAC database instability. This can cause high CPU utilization. I think that, which makes the switch unable to forward frames. We've already seen this. Unknown unicast frames is when the switches does not have destination MAC addresses in its MAC address table and must forward the frame out all ports except the ingress ports. I think that this is what I said at first, whereby a PC or a device will send a broadcast message. When a broadcast message is sent, automatically this one here doesn't have a destination, because it is designated to all the devices in the network. Therefore, the switch will forward them to all ports except the port where it came from. Broadcast storm. A broadcast storm is an abnormally high number of broadcasts overwhelming the network during a specific amount of time. I told you that we shall come up with what are called the links or the ports on the switches will be flooded or will be overwhelmed. They will be full of same single packet or same single MAC addresses moving, keeping around. Then it creates what are called the broadcast what? Storm. A broadcast storm can disable a network within seconds by overwhelming switches and end devices. Broadcast storms can be caused by the hardware problems such as faulted NIC or from a layer 2 loop in the network. Layer 2 broadcasts in the network such as ARP requests are very common. Layer 2 multicasts are typically forwarded the same way as the broadcast by the switch. IPv6 packets are never forwarded as a layer 2 broadcast. ICMPv6 neighbors discovery uses a layer 2 multicast. A host could caught in the layer 2 loops is not accessible to other hosts on the network. Additionally, due to the constant changes in its MAC addresses table, the switches does not know out of which port to forward unicast frames. So loops will continue. So to prevent these issues from occurring in the redundant network, some types of spanning tree must be enabled on the switches. Spanning tree is now enabled by default on a Cisco switch to prevent layer 2 loops from occurring. Getting that? So when you're using a Cisco device, you know that already STP will be enabled immediately to prevent such challenges. Spanning tree algorithm. STP is based on an algorithm invited by Radia Palman while working for Digital Equipments Corporation and published in the 1985 paper on algorithm for distributed computation of the spanning tree in extended LAN. The one who came up with this is, I had told you already that spanning tree protocol is an algorithm which was made by this Radia Palman, and this was when he was working about the digital equipments corporations in the company, then published in 1985, and then into the paper of distributed computation. Her spanning tree algorithm STA creates a loop-free topology by selecting a single root bridge where all other switches determines a single at least cost path. I think that I told you that always the spanning tree will be working under the priority, and again the time, the cost. Getting that time, cost, and all these things. STP prevents loops from occurring by configuring loop-free path through the network using the strategically placed blocking state ports. The switches running STP are able to compensate for the failure by dynamically unblocking previously blocked ports and permitting traffic to traverse the alternative path. That is when one path has been blocked, and then probably when the packet is trying to take that path, then or might be both one of the side is also blocked. What it will do, it will unlock the one that is blocked, and then the one which is manually blocked then it uses the one which was not blocked at a time. Spanning tree protocol, spanning tree algorithm, how does the STP creates a loop-free topology? Selecting a root bridge, it have to first select a root bridge. Are you getting that? I told you that it will always have a queen or a king, or probably it can have a master. Are you getting that? So we can call it a master. So that is a root bridge. So this bridge, in bracket a switch, is a reference point for the entire network to build a spanning tree around. Are you getting that? So that when it creates a master or a root bridge, it will always assist it to create on how it will be able to draw the what? The tree, the topology, the tree, spanning tree topology. Getting it? Then it will have the block redundance path. STP ensures that there is only one logical path between all destinations on the network by intentionally blocking redundant path that could cause a loop. Are you getting that? So when you have a tree, the word spanning tree, it means probably to make a loop or a tree to be a loop free. Are you getting that? So if you have a network that is connected to each other to every node, and there is no any link, all links are connected to each other. So what you do is just to make a free loop, just to disconnect one or to block one single port so that you can continue. 2. The third is create a loop-free topology. Blocked port has the effect of making that the link, non-forwarding links between the two switches. This creates the topology where each switch has only a single path to the root bridge. Getting that? They have one single path in the root what? The root bridge. Similar to the branches on the tree that connects it to the root of the what? The tree. Are you getting that? Most of these things when I will be doing the practicals, we shall be able to look at it first. I will explain topology, this using our board, and explain all these parts that you're looking at here. Altogether, I'll get to in another video where I will be drawing and try to explain them properly. Yeah. So have recalculate in case of a link failure. The physical path still exists to provide the redundancy, but these paths are disabled to prevent the loops from occurring if the path is ever needed to compensate for the network cable or switch failures. STP calculates the path and unblocks the necessary ports to allow the redundant path to become active. This is when now, when the STP is recalculating, it finds out that the port that was supposed to use is also blocked down. I get it, because you may go there, you as a network administrator, you actively be able to block that port. When you block that port, it means the packet will not be able to pass there. So what was blocked by an STP packet, an STP algorithm, then when it is going to call, it will reblock it so that you can be able to use that one, and then use the one that you had already used. So here you can observe, or might be here we are supposed to have something like a video and see how everything is moving. Okay, let me try to end here because of these guys who are making noise for me, trying to do their work. Probably I'll continue from here and I'll end it on slide 20.